Welcome, everyone, and thank you for joining us today for this webinar titled Next Gen Water Filtration, Harnessing Filtralite's Performance, organized by Smart Water Magazine and Filtralite. My name is Cristina Novo, and I am Technical Editor of Smart Water Magazine. Amid escalating concerns over water scarcity and pollution, the demand for advanced water treatment solutions continues to grow. At the forefront of this effort is the innovation in filtration media. Used to remove impurities, contaminants, and suspended solids from water, filtration processes are key to the efficiency and sustainability of water treatment solutions. Advanced filtration technologies are essential components of modern water treatment systems to improve operational efficiency and reduce resource consumption. Today, we're going to hear about Filtralite. Developed by the Saint-Gobain Group, Filtralite is a filter media with unique porosity that improves the retention and absorption of contaminants, allowing for greater volumes of water to be filtered more effectively. In this webinar, industry experts will explore the role of Filtralite in several applications: drinking water treatment, pretreatment for desalination, and wastewater biofiltration. They will explain how Filtralite can enhance water production capacity and reduce operational costs while contributing to superior water quality. After the presentations, we're going to have a question and answer period. You can ask questions via the chat window in Zoom. Please identify yourself and your organization when you ask your question. You're also going to see some poll questions on your screen. The webinar should last about 1 hour in total. And now I would like to introduce the speakers. The first speaker will be Alexandre Branthon, Sales Support Coordinator for Filtralite at Saint-Gobain. After earning his master's degree in political science, Alexandre worked at the headquarters of Carrefour in Paris, and later as a business engineer in the defense sector at Naval Group. He moved to Sweden 2 years ago and joined the Saint-Gobain Group in 2023, where he's now part of the sales team. The second speaker will be Mohammed Kastawi, Area Sales Manager for the Middle East and North Africa region at Leica International Saint-Gobain. Originally from Egypt, Mohammed lives currently in Riyadh. He has 17 years of experience in the Middle East in the field of pumps, water heaters, and solar energy. He joined Saint-Gobain Group in 2023 as the Area Sales Manager for Filtralite for the Middle East and Egypt. Welcome, Alexandre and Mohammed, and please go ahead with your presentation.
Thank you for this introduction, Cristina. It was really nice of you. So, as you said, this webinar is going to be about Filtralite, and I will do a short presentation, and Mohammed is going to continue about it. So, on the next slide, we will see the agenda really quickly. So, we'll start with the presentation, and to speak a bit where we are belonging with Saint-Gobain and Leica at a glance. After we'll see the different application for Filtralite. We'll see the difference with the traditional filtration media. What is Filtralite? After the performance, the many references we have already, and we'll come to the conclusion. So just to start a quick presentation of myself, Cristina did already quite a bit, but yeah, I studied political science in Paris. All the political area in France, it started to be more interesting even right now. So I did that for my master. After I was working for 2 years in Carrefour headquarters. So Carrefour is a big company in mass distribution that is based in France, but is all around the world. I've been working also a bit as a journalist and also for Naval Group. It's a company that builds submarines all around the world also. And I moved to Sweden 2 years and a half ago, to discover other perspective and to have another part to see different lifestyles, but I joined mainly like Saint-Gobain Group and the sales team of Filtralite since a bit more than a year now, where I'm in charge of the marketing, the communication, like the CRM, the reporting, and planning the production and the stock, and also the follow-up on overdue invoice. So anytime you will have any order with us, I will be in contact with you and I will do all my best to help you to have a smooth process. So just to introduce Saint-Gobain at a glance, like if you don't know Saint-Gobain, Saint-Gobain, it's a really old company. It has been made in France like more than 360 years ago. At the beginning, it was for the king, like Louis XIV, like to build this big palace they have close to Paris, like in Versailles. And it was really the beginning of this company. It's one of the top 100 industrial group around the world with close to 1,000 production sites. There is many, it's split in many trademark and brands all over the world. There is some, you know, as Weber, Securit, Placo, Gyproc, or even PAM that we are working close by, like they are working in water distribution, like for the pipe. It's close to 200,000 employees in the world, and we are present in more than 85 countries. So it's really well known in France, and I guess you know it also where you are belonging to. And just to finish, like for my part, I will introduce you LECA. So LECA means lightweight expanded clay aggregate. They are the market leader in Europe. For the ones that are not familiar with that, it's this kind of a small ball of clay that you can find in the pot for the flowers. But we are using it for many different applications, as for housing, infrastructure, and water management. There is actually one big project, like for LECA, is to build a really big tunnel, like between Denmark and Germany, like to make closer Copenhagen, like to Hamburg. And it's a big company with more than 400 employees, and we are present mainly in Europe, and we have many projects there. So right now I finish for my part, and I will let Mohammed present himself. And thank you,
Alexandre. Yeah, thank you, Christina. Thank you, Alexandre. It's always, Alexandre, it's impressive to see, I mean, how big is our company and tell the history about Saint-Gobain. It's last for 360 years. So thank you for giving this opportunity, and thank you for our attendees who is coming today in order to know more about Filtralite. And to start with, so just a quick introduction about myself. My name is Mohammed I'm basically from Egypt. I hold a Bachelor of Mechanical Engineering, and currently I'm doing my MBA from Liverpool. I have experience for 17 years, mainly in pumps. I worked with different companies. Recently, I joined Saint-Gobain in last September as an area sales manager for the Middle East and North Africa. So moving to the application. So let's see what are the applications that you can use Filtralite with. So starting, as we can see here, so Filtralite can be used in many solutions, as in drinking and wastewater, such as traditional when it comes to traditional physical filtration. So like desalination or tertiary treatment. And in this stage, as we know that the key element here is to the retention of the grains and the storing of the suspended solid. But also in case of biofiltration, Filtralite is a practical solution where we are looking for growing the bacteria, and Filtralite is like an excellent media for these biofilters. In wastewater, such an example, we will see at the reference one of the oldest and biggest wastewater treatment in Oslo, and this is lasting for 30 years. Also, in case of that, you need to remove like nitrates in drinking water or any other like iron and manganese. Also, Filtralite is a practical solution for that. So what is the traditional filtration media that we can see, and what are the challenges that from our point of view, our customer are facing? So this is like a simple drawing. It's showing that the filter media, where we can know that it's okay, it can come as a one layer, most likely it's sand, or two layers where the customer is are using sand and anthracite. So mainly they are using sand in the bottom and anthracite as a top layer. So here, our first point, what we can see as a challenge is this retention of the sand. As we know, sand mainly is like a solid part, so its retention capacity, it's very low comparing with Filtralite. When it comes to the filtration rate, it's mainly between 4 meters per hour and 12 meters per hour. So in case of you want to increase the production, you have like up to limits of 12 meters per hour. Also, for the both solution, we can see one of the challenge, which is the low or the big head losses that you can see during the operation caused by this media. At the same time, the expensive in OpEx when it comes to the operation, and also while having this intermixing layer. So as we know, the bulk density of sand is around 1,600 kilograms per cubic meter. And for anthracite, it's mainly from 800 to 900 kilograms per cubic meter. So just imagine that you have these two layers, and once you stop the backwash, and you have this intermixing the layer between anthracite and sand. So by gravity, the sand will drop, and then the anthracite, but you will have this intermixing between them. And this, of course, will cause to low efficiency in the system itself. So these are the challenges or the obstacles that we can see in this system. So what you can expect when you want to change. So first, let's talk about what are the optimization and what are the improvement that you can expect. So first point, if you have a sand, anthracite, pumice, any other kind of media working in a sand filter, then you have to know that it's very easy and quick to remove it and use the Filtralite. So you don't need to change anything in your plant. Just we need to remove the current media and install Filtralite. When it comes to filtration rate, so as we can see here, it's up to 20 meters per hour. So that means you can increase the production of your existing plant. But from the same time, when you are using the other media, you can expect like frequent clogging. And this issue can be solved by Filtralite. And we will explain that in our presentation, how we can solve that. Of course, doing a lot of backwash, then you're using a lot of frequent water in the washing, then it will end up that you are losing a lot of water. So also this part you can save. When it comes to the SDI in desalination, also you can expect that you get a better or a low number of SDI, and this of course will cause a better water quality. So this in total, what you can expect, but let us just jump to what is Filtralite and how we are manufacturing this media. So basically, as we can see this in this picture, Filtralite is a clay. So the main raw material for Filtralite is a clay. We choose this based on the purity, particle size, distribution, and other qualities to assure product quality. So this selected clay is crushed and stored. We dig in the ground, we get this clay, and we crush it and store it into fine particles, make it lightweight aggregates. And then once the clay is ready, it's mixed with water and other ingredients to make sure that the end product is better. And then it comes to the heat treatment, where we have this rotary kiln or like a furnace, where we can heat the media inside the Filtralite up to 1,200 Celsius. And then you have all the organic material inside the clay and turn into gas and evaporate. And then you have this clay expand. So as you can see here, 1 cubic meter, it goes inside the furnace, it ended up with 3 cubic meters. So you will get like expanded clay, and at the same time, you will have a lighter media. And then goes to the cooling part, where you can cool this media to the ambient temperature, and after that you can crush it or screen it, obtain particle size distribution. So at the end, we will get different particle size as a grains size and different densities. And then it goes to the quality control, where Filtralite are quality controlled through the manufacturing process to meet water filtering and other criteria, and to be evaluated by our team, and then make sure that it's have very good quality. And then we do the packing and delivery. And when it comes to the desalination part, we hold an NS and NSF certificate for Filtralite Pure. This picture explains how Filtralite is a unique media comparing with other media. So it's explained the benefits of using Filtralite. As you can see here, Filtralite has a higher porosity comparing with sand, which gives you more storage capacity in terms of if you're doing this when you want to run the filter for a longer time till you stop and do the backwash. So the reason of that you are using the depth of Filtralite in a much better way than sand. So cause that with the sand and anthracite is get clogged in the top layer. So as we saw in the previous slides, you have the anthracite on the top, let's say, and the sand in the bottom, and then you got the clogged from the top layer. But with Filtralite, you can avoid that because you are using the whole depth of the media because of this porosity, as you can see in the picture. And then at the end, you will have a less backwash, means less energy consumption. And it's especially an ideal solution when it comes to the product or to the projects or the sites that the customer want to produce more water. And by using Filtralite, they can increase the production of the plant without increasing the number of the filters. And also we are going to see some cases, live cases for this. And also, as we know that for this high porosity is a good feature that will allow you to remove more suspended solids. And of course, this will affect in your backwash, as we said. So in terms of OPEX and CAPEX, and I'm just putting this OPEX and CAPEX in two terms because we can target the new plants as well as the current one. So if you are an operator and you are doing and you want to save OPEX in your current plant, which is already in operation, then by using Filtralite, you can expect that 2 to 4 times having less backwash. So you will get a higher filtration rate, so more water in the same period. In case of the RO plant, you will have a more stable biological water coming from the filter, which means less biofouling to the membrane. Then you can increase the lifetime of your RO membrane. Of course, you will have less cleaning replacement of the cartridge. And at the same time, you will be allowing to have more suspended solid in the feed water. So that will give you also a longer time to stop and do the backwash. But let's say that you are a new customer, you are a customer and you are building a new plant and you are caring about CAPEX. Then again, Filtralite is an ideal solution because as we said that you can expect that you are increasing the filtration rate. Then let's say that instead of using 10 filters, you can be able to use 6 or 7 filters. That means less footprint, saving in backwash and concrete and steel. And also because the Filtralite is a lighter media comparing with other media, then you can be able also to use a smaller backwash. Of course, this will give you again, it will impact your energy consumption. So this in terms of OPEX and CAPEX. So what are the solution and how we can give you Filtralite as solution? We can provide you in 2 options. So the first one is to have 1 layer of Filtralite. And as you can see here on the left side of this picture, and this is mainly recommended for the depth of up to 1 meter or 1.2 meter. But if you look to the right side and you have depth more than 1.2 meter, let's say that you have a 2 meter of a media, and then in that case, we can provide you with 2 layers. As you can see here in the bottom, you will have a layer with a smaller grain size, but higher density. And in the top layer, you will have the exactly vice versa. So you will have lighter density, but with a bigger grain size. So you have the coarse layer and the fine layer. And in that case, you are using 2 different grain size, 2 different density, and this is how you can overcome the intermixing layer that we saw in the previous slide. So you stop the backwash, and then you have the bottom layer with the higher density goes down first, and then the lower density with a smaller grain size on the top. And this is how you can keep the same performance of your filter. So let's see now, and I'm sure this is like a very, I'm getting these questions many times. Okay, I want to see how is Filtralite is performing against other media. And it's an important question. And the customer have the right to see when he do this investment to change to Filtralite, what kind of performance that he can expect. So what I'm going to show you today, that 4 different cases, and all of them it's done by third party, not by us, but by a third party. Either it's like an engineering institute or done by one of our OEM's customers. The first one we have from Ingopras. So in that case, it's very important case to the customer who's looking to see the turbidity or see the suspended solid. So here we have two ideal comparison. One, Filtralite with a grain size 0.8 up to 1.6, combined with sand 0.4, 0.8. And to have like a fair comparison, we did the same exactly. We choose the same particle size instead of Filtralite. We choose anthracite with the same grain size 0.8, 1.6, and again combine it with sand 0.4 and 0.8. And we did this experiment in different strategies. First one, it was 80, using an input as a suspended solid with 80 milligram per liter as a suspended solid. And we choose different filtration rate. One is 8 meter per hour, secondly is 15 meter per hour, and then 20 meter per hour. What are the parameters that we are going to measure? First one is the turbidity, NTU, and the suspended solid. So practically, how much this media can reduce from this 80 milligram per liter as suspended solid by using this media. In the first case, with anthracite combining with sand, it was the input 80 milligram per liter as suspended solid, and by 8 meter per hour, 15 meter per hour, 20 meter per hour, I'm just highlighting this one, but the difference goes for all of them. But as you can see here, from 80 milligram per liter, it dropped from 80 to 64. So from 80 to 64, while you have a turbidity of 12.7. So what Filtralite can obtain here, it's dropped from 80 to 9.1 or 9.2 with a turbidity 1.58. So can you see how much is the difference between both of them? To this one, the turbidity is 12.7, and this one is 1.6 almost, while the suspended solid, the outcome from the filter is 64.75, while with Filtralite, it's 9.17. And even this gap is going bigger when we increase the suspended solid, or when we did the test in a higher suspended solid. Like here from 200, it dropped to 163 with a turbidity of 35, while here it's dropped from 200 to 44. So from 163 to 44. And again, the turbidity, we are getting a better turbidity, this from 35 to 7.5, so 7.8. Again, for the 350 milligram, the same. And in this one, the gap is going even the biggest. So from here, it's 350 dropped to 343, almost, with a 78 turbidity, while here it's dropped from 350 to 99, with a turbidity 20. So in all cases, we are getting a better turbidity, better quality of water. At the same time, we are reducing more or storing more suspended solids in the filter. Case number 2, it's done by Swiss, and all of us, we know Swiss very much. So one of the biggest OEMs globally. So Swiss, they did an experiment. They had 5 columns, and they want to check the turbidity and UFRV. So let's start with turbidity. So they used, the first column was sand with a 0.75. The next column, second column was sand 0.95. And then the third one, anthracite with sand. And then one layer of Filtralite with a dark green, and 2 layers. We called it mono-multi. So mono-multi, it's 2 layers of Filtralite, which you can see in light green. Of course, we have fixed the same parameter for all the 5 columns. In this case, as you can see here, the turbidity is giving the best numbers when you go to the green one, which is Filtralite. And even it's gone better when we use 2 layers of Filtralite. As you can see here, it's even dropped less than 0.1 as a turbidity. At the same time, and this is very important because the UFRV, so practically here, how many cubic meters will go by square meter. So in a different way, here, when you use the best solution for the first 3 columns was sand and anthracite, it was like they reached 1,250 cubic meter per square meter, and then you had to stop and do the backwash. While with Filtralite 1 layer, it goes from 1,215, it exceeded 1,750, and then it stopped, and then you need to do the backwash. And even it's getting better when you use 2 layers of Filtralite mono-multi, then it exceeds 2,500. So just imagine that you have the same filter, same quality goes inside the filter, but instead of you are doing 1,250 cubic meter per square meter as a UFRV, and then you had to stop, you are giving yourself like a longer time for the filter to run a longer time, either to use 1 layer of media or Filtralite to reach 1,750, or to have the double exactly and have 2,500. And this how Filtralite is performing in terms of turbidity and UFRV. Also in this one, we have here 2 layers, but different filtration rate. One, we have it in 8 meters per hour, the one in green, dark green, and the dash one is with a 15 meters per hour. And as we can see here, we are getting the same amount as a production with a higher filtration rate. That means you are doubling your production of your plant. And in that case, Swiss, they want to make sure that the turbidity, you are getting a better turbidity. So they put this as a benchmark to have below 0.5. And even when we increased the filtration rate from 8 meters per hour to 15 meters per hour, still we score 0.3, which is below the 0.5. So we are getting good quality of water, and you are doubling your filtration rate or filtration production. Goes to case number 3, is done by Spiri. And in that case, this one done in Spain, in the desalination plant in Spain. And you want to see how Filtralite is performing for the TOC remover, for the total organic carbon. And as we know, it's a very important aspect, especially in the desalination process and in a system that utilizing reverse osmosis or other membrane as a technology. So in TOC remove, in TOC, in the feed water, it can cause the fouling and scaling of the RO membrane, leading to decrease the efficiency and to increase the operation cost. And so this one is very crucial when it comes to remove or reduce the TOC remover. So in that case, they had a TOC an average with a 5 meters per hour. Using sand and anthracite, it was only able to remove 37%. While using Filtralite, it was able to remove 50%. When we increased the filtration rate from 5 meters per hour to 15 meters per hour as an average, it was 26 only, but with Filtralite, it was 40%. So this is how much you can increase the, let's say, the amount of TOC removal in your water. In terms of SDI, the one you can see here in the red line, it's for the SDI input. So during 1 year, complete year, as you can see, always Filtralite with the blue color is scoring better results in terms of SDI. So you can see here all the time during the year with a different input of SDI, still Filtralite is scoring much results comparing with sand. To the fourth case, we have done by Swiss again, and they did something called variability test. So one of the points, very important points about Filtralite, that for how many years you can use it. In our operation manual, we are saying that if you use Filtralite and use our protocol of backwash in the right terms, then Filtralite can last for 25 years. And I was surprised to say that we have some plants that's still operating from 30 years back till today. So how the customer, they can measure that? So we did this variability test. So we did it in the same almost particle size, Filtralite comparing with anthracite and pumice. So what they did in this experiment, they brought one cylindrical like column, and they put the media inside, and they put like a solid part. And you have this element. It's like the clock watch, okay, moving inside. And this element goes with the 15 minutes with a 150 strokes. That's mean 325 rounds, full circles. And then again with 30 minutes with 1,500 strokes. So practically they are making this particle site inside this cylinder is hitting the media, and see how much this media will be impacted by this heating element or this elemental and this solid parts. So it's like comparing, or you are using like a suspended solid inside the water and see how much this media will last for. So they have this parameter with the 15 minutes So if you score from 15 to 20%, that's mean you have a poor media. If you score 10 to 15, then you have a good media. While if you score 6 to 10, then you have a very good. And when you have this very good, that's mean it lasts for a longer time. So this for 15 minutes. Let's go here for the 15 minutes to see how much all of them they scored. So for the one for 15 minutes, the pumice scored 18.4, which is lost here from 15 to 20, while anthracite scored 15.3. Again, it's here in the poor part, while Filtralite scored 8.4, which is here exactly in the very good. The second one for 30 minutes, and again, jumping to the right picture, as you can see here, 30 minutes with a 1,500 strokes. For pumice, it scored almost 30, which is here in this part as a poor. This one, again, anthracite around 28.4, again in the poor sector, while Filtralite scored 14.5, which is even better than the very good. This experiment, we can send it to you, and you can just push the link, click the link, and it will take you directly to the website of Swiss, where they have all of this information that I mentioned, and you can see all the results coming from this one. So this was like our first case to have this performance Filtralite against other media. And then let's talk about the references. As Alexander mentioned in the beginning, I'm here based in the Middle East, and let me say that's very clear. We have a reference globally around 750 plants, either desalination or drinking or wastewater. It's been running with Filtralite since many years. So it's not a new product. It's not a new company, as you saw, but we are we now have our first steps in the Middle East. But for our good luck that we had now some references in the Middle East. So I will explain this reference globally. And of course, these references either in the Middle East or globally, it's as per your requests. Whenever you request it, you can send us directly. We will send you the full information about these plans, for how many years it's running, which exact model we are using, and who is our customer, and what is the type of this plant. So let's go to the first case study. So in this one, in Thames Water, and in this one in London, in this case, the customer had a major problem in the water quality, especially from July to November, due to the high number of algae in the water. Plus, also, they wanted to increase the production of this plant or the capacity of this plant. And that was done in 2001, when the population in London, it was increased, and Thames Water was being asked that we want to increase the production of this plant. So they did screening for all the media, and commercially and technically. And they want, as we said, they want to increase the production and also having a good quality of water. They decide that they want to go with Filtralite. They did this experience for around 5 medias, different media, and they ended up that we want to use Filtralite. What was the result? And it's a very important question, because you need to understand that when Thames Water, they change to Filtralite, they gains a very unique results. The first one was they were doing the backwash every day, every single day there was doing a backwash process. Now they are doing the backwash every 3 days. So just imagine that in 1 month, you're doing 30 backwash. With Filtralite, it's only 10 times per month. Multiply it by 12 months, then you can see how much they are doing the backwash. It's a third. You are having the third exactly numbers of backwash during 1 year. And you will be able to doubling the filtration rate from 5 meters per hour to 10 meters per hour. So this plant production is having 2.6 million cubic meter per day. And that time, the cost saving was 10,000 pounds per filter. Just imagine that they have a 48 filter. That means in 2001, they were saving around £500,000 every year, only from this part. Just imagine how much they are saving these days with the increasing of of course, the electricity. Of course, we have all of these cases. By the way, we have a full documented reports done by our customers. So also you are most welcome to ask. We will be able to send it to you with all the full details. Now to the next one, which is VS. and very proud to talk about this one. I've been there by myself in last December, and this is the largest wastewater treatment plant in Norway with a capacity 100 million cubic meter per year. This plant is built in 1984. In 1994, after 10 years, they had a problem that this plant is being built under the mountain, and they have very limited space to increase the number of filters in this plant. And the population increased in Oslo, and they want to increase the capacity of this plant. So in 1994, they decide that we will go with Filtralite. They will be able to increase the filtration rate. We have a huge record in terms of long time or long-term lifespan. Because this plant is running since 1994 till today. So that's almost more than 30 years. It's still running with the same media. Also, we have a full report about this one. You are most welcome to ask about. The third one, we had a full scale. It's done by Aquamed. It's done in Spain. In a desalination plant, pre-treatment. They want to measure the consumption of backwash and the number of the backwash during the month. So let's take this as our benchmark for sand. It's called 100 as a consumption of backwash. And then you will be able to reduce it with using sand and anthracite from 100 almost to 75. But with sand and Filtralite, and I'm highlighting this one, sand and Filtralite, not only Filtralite, they'll be able to reduce from 100 to 30, almost 35. That means around 65% of consumption of backwash is saved, goes to your production in the plant. So just imagine that with sand and Filtralite. And this is a very good point. I want to echo this point again, that Filtralite, it can be used with sand or it can be used alone with the two, as I said in the beginning, one layer with a depth like 1 meter depth, or two different layers with different densities or different grain size if you have a bed around 2 meter or 1.5 meter. In terms of backwash, again, it was 12 backwash. With sand and anthracite, it was almost 9, while with sand and Filtralite, it's 4. Again, of course, you can use this one as a solution, use sand with Filtralite, or even get the optimum result if you used only Filtralite, like we saw in the experiment done by Swiss with a green, the light green line and the dark green line. The last one, this one is a Benisab desalination plant. This one done in Algeria. It was in 2020. This one, the capacity was 200,000 cubic meter per day. They had 48 filters. The water losses in 4 months was around 673,000 cubic meter per day. And it was only allowed to get and feed water with a suspended solid up to 25 milligram, and then they had to stop and do the backwash because it got clogged. So the first stage was to change in 2020, change 24 filters, and the water loss dropped by 45%. But from the other hand, the suspended solid limit increased from 25 milligram per liter to 40 milligram per liter. And in this stage, the customer decided, I want to change the whole filters. So they changed it, and they have now the suspended solid allowed going from 25 milligram per liter up to 70 milligram per liter. And the water loss decreased by 85%. This plant now capacity is 300,000 cubic meter per day. It's running since 4 years till now, and it's done in Algeria. And I can just add this verbally now. We had some reference also with Metito in the Middle East. Now we have reference also with Veolia B6 in the Middle East, in wastewater and desalination as well. I hope that I didn't go very, very quickly or very fast. Now I want to close with the conclusion to give our attendees time to ask some questions. The conclusion, it's been in many applications, it was the best solution to use Filtralite. As I told you, it's now running for drinking water and desalination plants, more than 400 plants, and wastewater plants, more than 300 plants, some of them since 1994. It's very direct and easy to replace, so you don't need to change anything in your plant. Just remove your current media, use Filtralite, or if you are building a new plant, then you can save, as I told you, in terms of capex, you can save the number of filters. It allows you to increase the filtration rate by 50%. Sometimes, as we saw in this case with Thames Water, it was the double, and it can reach up to 20 meters per hour. It solves your issues when it comes to fast clogging or poor quality. It gives you more time to run the filter till you stop and do the backwash. It solves your issue about the short lifespan, so you don't need to change it every 5 or 10 years. For especially for the companies that they are thinking this project like a BOT or BOOT, then they are care about how much time I will change the media during this 25 years, 30 years. You don't have to consider that or be concerned about this point. Also, when it comes to the high energy consumption, in terms of the quality of water, you are getting a best quality of water in terms of SDI and TOC removal. When it comes to your return of investment, then in most cases, it's less than 3 years. And again, I'm saying that in a different way, it can be 0 years. So your return of investment, it can be 0 years. So just imagine that you want to build a new plant and you are expecting, as per your design, to use this sand, for instance, as a media, and your calculation is based up to, let's say, 8 meters per hour. So you need to build like 10 filters. With a Filtralite, this 8 meters per hour, it can be increased 50 or the double, 50% or even 100%. So you can decrease the number of filters. Then you just imagine how much you can save in terms of mechanical work, electrical work, how many pumps you are using. So in capex, you can save a lot. In that case, your return of investment is 0. You are getting the return of investment on the same time you purchase a Filtralite. These are our customers who trust us. We have been dealing with them for many, many years. Of course, this list is available. Some of them, they are, of course, exist in the Middle East, and most of them, they are existing in Europe and other countries in USA or India or the Asia part. At the end, thank you so much for this time. It's been a pleasure. I tried to make it very quick to give you some time for asking the questions. Of course, I'm available. You will get all the information after this presentation. And of course, you can ask your question. You are most welcome. We are here. So thank you, Christina, for giving us this rooming. And let's start with the questions.
Thank you. Thank you, Alexandre Branthon, Sales Support Coordinator for Filtralite, and Mohammed Kastawi, Area Sales Manager for the Middle East and North Africa region, both at Saint-Gobain Group. We've heard about the challenges with current filtration media and the added value of Filtralite over conventional filtration. And we've seen those impressive results obtained with Filtralite in several case studies, looking at turbidity, TOC, etc. And finally, the savings of up to 50% in OPEX in the filtration step, but also in CAPEX with a return of investment of less than 3 years. Now it's time for questions. So if you want to know more, we'll give you a few seconds to use the chat window in Zoom. Hello again. So we'll start with some of the questions. And we'll start with a question from Mohammed El-Darditi from Metito. And his question is, how does Filtralite act with channeling problems that occur in normal media?
Sorry, again, how Filtralite is done?
How does it work with channeling problems that occur in normal media?
So, okay, I think this one it's need to explain in more details, but I will try to make it like in a brief. So, in case if you have like a current media, and this media is being like one layer, like let's say that it's sand. So, what we can propose is you can remove the top layer of the sand and use one layer of Filtralite with a higher grain size and lower density. Then you can combine it with the sand. And the option number 2, you can change the full depth of sand and use a 1 layer of Filtralite, depends on the depth. Or if your depth is more than 1.2 or 1.5, then you can use two layers of Filtralite with a different grain size and different densities. Hopefully I answer your question. If you have more or you need to have more clarification about it, of course, we can able to contact you after the webinar. Thank you.
Thank you, Mohammed. We'll just take one more question also from the same person. And he was asking about the expected top-up rates for the media over time of operation.
As we mentioned in the webinar, yes, you can expect that it will run for a longer time. If you are talking about the lifespan, this is what you mean. So as we said that it's up to 25 years, even we have some plants running for 30 years. And this because the media itself, it have a very, I would say that, as we saw in the variability test, like it's not easily goes like to be scratched or be like closed in the filter, so you don't need to change it. The only concern that you may want to make sure that the media not escaping your filter, and you can doing that by using the right protocol for each model. And this, of course, we can provide you with specifically what's the flow you can use for air or water during the backwash.
Okay, thank you very much. So we'll go to another question, this time from Firas Jaish from Sawako Water Desalination Plant in Saudi Arabia. And the question is about the added value of using Filtralite compared to cartridge filtration or ultrafiltration.
Okay, so the added value. So in terms, as we said, in terms of OPEX, you can expect 2 to 4 times less backwash. In terms of the if you talk about this biofouling point, then you can expect that you have less biofouling because you are using a media with a higher surface size. So in that case, you are growing the bacteria more inside the media, so you are avoiding this biofouling to happen in the membrane. That's you are giving a membrane a longer lifetime. In terms of also of OPEX, you are using a smaller backwash pumps because you are using a lighter media. Then the density for Filtralite, it's up to like for some models it can go up to like 550 kilograms per cubic meter. That means you need around 550 kilograms to fill 1 cubic meter. While if you goes with sand, it can goes from 1,600 to 1,700 kilogram per cubic meter. So just imagine that you want to lift up 1,700 kilograms or lift up 550 kilograms. Then you are using a smaller backwash. Of course, the number of backwash will be decreased, and the water consumption, you will have a lot of water, using a lot of water consumption in terms of the water you are using in the backwash. This to explain very quickly, and of course, we can provide you with more data if you want. Yeah, thank you.
Thank you, Mohammed. Since you're speaking about the backwash frequency, we have a question about that from Prayhot Kalsharkar from Vasu Chemicals. And the question is, and I'd like to understand the backwash frequency per day.
Yeah.
In the specific case of a suspended solids load of more than 18 milligrams per liter. I don't know if you could speak to that.
Yes, 80 milligram per liter. So as we saw in this case, a study case, when we had 80 milligram per liter for a suspended solid, Filtralite was always performing better than against anthracite and sand. So in terms of backwash, for each model, of course, usually we send to our customer like questionnaire where we collect some information about either the designing of the new plant or the performance that you are getting for the current plant, if you have one in operation now. Based on the information you give us, we propose a different model or different grain size with a different density. With the proposed model, we give you our protocol for backwash. And it's like the normal one, but you will use, as I said, you will use a low flow comparing with other medium. So you will use either a smaller pump or you can use the current pump with a VFD to use a smaller flow. So this protocol will give you based on the model, and this, of course, available as per your request. Thank you.
Thank you. And we got to another question. This time is from Jose Sonnenschein from CTA in Israel, and it's about biofilm growth. So biofilm growth in osmosis membranes with high dissolved solids, water. I don't know if you could.
Yeah, but what is the question exactly? So
I think it's just maybe a general question if you could address this.
Okay. Yeah, as we explained, with Filtralite, you can expect a less biofouling inside the membrane because you are giving like a bigger grain surface size for the media. So that's allow the bacteria to grow more inside the filter. So this will avoid to having the biofouling inside the membrane in the next phase.
Okay, thank you. Another question, this time from Swed Anes, Senior Project Engineer at Metito Overseas in Qatar.
Okay.
Can Filtralite be used for stormwater filtration system to replace the air filter system to remove oil or any chemicals? Or if this has been experimented with groundwater filtration systems?
Okay, I think this one need more clarification to answer this question. But if you are using a sand filter currently, a sand filter, so you have a sand or any media like anthracite or any other media, and you are using this stormwater, of course you can use Filtralite. If I get your question in the right way, if you are talking about using the chemicals or reducing the chemicals, of course we able to reduce the nitrate, iron, manganese, and we have a full chapter about that, talking about this part exactly. In the handbook of Filtralite, of course, we can share this with you. But of course, I'm going to need more information about the current situation in your plant. Then I can contact you after this webinar. Thank you for your question. I can contact you after that and get this information and get back to you with the exact result or estimation.
Thank you. We had another question about stormwater. This was from Ani Lutu from NEOM in Saudi Arabia. And the question is about what solutions do you have for attenuation and treatment of stormwater and applicability in hyper-arid climates?
Then again, I mean, I see this question coming for the stormwater. Okay, in a stormwater application, if you are planning to do like a filtration and you have this water coming from the station of this stormwater, and this water need to be filtered. It's based on the quality of the water that's going inside the filter. So again, if you are using like this media, kind of media, like sand or anthracite or any other media in this filter, then again, yes, you can use Filtralite. But I think this needs to be answered. We need to have like a long discussion about it. So if you might, Christina, just highlight this question, and we can be able to get more information about it from the customer and answer it maybe in different case or different call.
Perfect, thank you. And let's go to something else. This one is from Maimun Shabouni from NWC in Saudi Arabia. And he asks about how we can use these filters in tertiary treatment. Yes,
it's a good question. So in tertiary, as we know, we have in the third stage, we have the filter part. So in this part, in tertiary, you have this filter before the end, and you are using currently what I can see now from the National Water Company that mainly focus on sand, or either using sand or different, or combine it with different media, either anthracite or pumice. So the good thing about Filtralite that yes, it can be used with the same filter. And as we said in the beginning, you can use two options, either to change the top layer with Filtralite or change the upper and lower layer. And of course, you can expect that Filtralite, it will go into store more suspended solid. It will give you a higher production in terms of the capacity of the plant, better quality of water, less backwash. And this is a good question. I think it's more, Christina, relevant to the initiative running by National Water Company in all of the Kingdom of Saudi Arabia for something they called the long-term project, where they have these tertiary plants and they are given to like a contractor or OEM who is operating this taking this as a BOT for 15 years. And in these projects, mainly the customer, they are looking to either to use a less of filters or increasing the capacity of the plant. And both of them, it can be able to done by Filtralite. And I would like to take this, of course, in more details with National Water Company. If our customer have more time, we can arrange that either face-to-face in Saudi Arabia, or we can do it online as well. But thank you so much for your question.
Okay, thank you very much, Mohammed. So we're gonna take another question, which is specific about the chemical consumption. So it's what are the calculations of chemical consumptions for pre-treatment, mainly coagulants, using Filtralite? I don't know if this is too technical to address now.
Yes, it is, and usually, yes, what we can confirm that by using or doing a less backwash, then you can use a less chemicals. So let's say that you are doing the backwash 4 times per day, and you are using chemical in these 4 times. So by doing the backwash 1 per day, of course you are going to save chemical. But to know exactly how much, of course, this need to do like a pilot, because it's different from case to another. But of course, it will reduce your using of chemicals during the backwash. This for sure.
Okay, thank you. We had a more general question, which was concerning the main differences in the performance of Filtralite when used for drinking water treatment versus pre-treatment for desalination.
I'm not sure if I understand. I get the question. So comparing drinking with
the performance of Filtralite when used for these 2 different applications, for drinking water treatment or as pre-treatment for desalination.
Okay, so in drinking, as we saw in this Thames water done in London, 2.6 million cubic meter per day, they had this comparison between Filtralite and other media. And as we saw, when it comes to the results, yes, it performed better. It's now they are doing the backwash 1 every 3 days instead of 1 every single day. They will be able to increase the filtration rate from 5 meter per hour to 2 meter per hour. And of course, this impact the saving in energy. They saved around 10,000 pounds every year for each filter. And this 48 filters in total. So that's almost £500,000 saving on only changing the media. Of course, you can expect the same with a less backwash using smaller backwash pump. From the water consumption, all of this will goes in the improvement that you can expect, either it's in the pre-treatment desalination plant or drinking plant or even tertiary wastewater plant.
Okay, thank you very much. Then we have some questions about implementing Filtralite. So something specific about the underground nozzle system inside the tank, if there's any specific nozzle that shall be changed to get compatible with the Filtralite media. This is from Hassan Amer from Metito in Egypt.
Okay, Hassan, thank you for your question. Maybe I didn't make this point clear during the webinar. Sorry for that. So Filtralite, you need to use it as a replacement for any other media, but in all cases, you need to keep the gravel or the media support level. So you will have the gravel or the media support layer, and then you have on top of that the Filtralite. So let's say that you have this gravel, 3 to 6 millimeter as a media support, it will remain the same. But what you have on top of that, either it's sand or sand on anthracite, this is what we are talking about. So if you use Filtralite, yes, you will keep the same nozzle and the same gravel in the bottom layer, and we will give you our proposal based on the grain size that you currently have. Either it's 1 layer or 2 layers.
Okay, thank you for explaining that. And this one is about a product, and this is from Ahmed Wahid, Deputy Technical Manager at Swellem. what are the available grain sizes and densities?
Okay, again, a good question. Yes, we have from 0.5 millimeter up to 8 millimeter. Of course, it's different from model to another. We have like the HC 0.5 to 1, from 0.5 millimeter to 1 millimeter. We have the NC 0.8 to 1.6. So it goes with a different grain size. Again, we have, as we explained during the manufacturing of Filtralite, we are able to control when the Filtralite or the clay goes inside the furnace, we are able to control the heat. That's why we are getting a different grain size with a different densities. What we ensure to our customer that in case if he used 2 layers of Filtralite, he will get 2 different grain size and 2 different densities. So the density is starting from 450 kilogram per cubic meter up to, I think, 600 kilogram per cubic meter. But if he gets 2 layers, as I mentioned in the beginning, you will have 2 different layers with 2 different grain size. The one on the top would be the lighter density with a bigger grain size. The one on the bottom would be the higher density with a smaller grain size. And this is how you can overcome the intermixing layer. But thank you for the question, yes.
Thank you. Another question, this one from Annabelle Rulo, and she asks, she would like to know whether you already have had any biological denitrification of groundwater, so
Yes.
using Filtralite.
Yes, we have many cases, yes, and we will be happy to share it with you, especially about this specific question. Either it's like cases studies or some references where this was the main topic to do this biological treatment. Yes, we can share this with you, of course.
Yeah, totally. And the one in VS, it was denitrification, the case study that you present.
Yeah. Yes. Thank you, Alexandre. Yes, this the one also. It's as we said, it's running from years, and this was one of the cases that we want to solve in VS.
Okay, thank you. Thank you. And we have also a question about specific contaminant. So from Mariana Numi from the Grenoble-Alpes Métropole in France. And the question is, what treatments are available for Chrome 6?
For Chrome 6?
I don't know if this is a contaminant you work with.
Yeah. No, this one we need to check with our expert, but to make sure this Chrome 6, yes, what we can say that it when it comes to nitrates, iron, manganese, yes, Filtralite is a good media to be used during this kind of containment. But especially Chrome 6, I don't have an answer for this now, but we will get back to you as soon as possible.
Okay, thank you. And another question about the desalination application, also brackish water. It's if you have a case where you have less than 3 SDI, is it possible to avoid ultrafiltration in desalination brackish water treatment plants?
If they have less than 3 SDI, yes.
Yes.
Yeah, again, sorry, what's the question? If they have less
Is
than
it
3?
possible to avoid ultrafiltration in desalination brackish water treatment plants if you have less than 3 SDI?
To be honest, I didn't get the question, but I would assume that either if our client here is talking about getting a less SDI, yes, he can expect less SDI. If you have less than 3, he can expect even lesser than 3. And I mean, some customers, they are like, okay, they are okay with to have like 5 SDI or 4 SDI. Of course, if they change to Filtralite, this is not only the parameter that you can expect that to reduce the SDI, but a lot of terms like we explained in OPEX and CAPEX. Not sure if I get the question. Hopefully, I answer your question, but we can take this also after the webinar. I can contact you and understand the question in more details.
Thank you. And now it's a question looking at the future. And this is from Willem Birden from Ecopomics in Turkey.
Yeah.
And it's considering the sensitivities regarding carbon emissions. How do you see the future of filter media in the coming years?
This is this is a smart question regarding carbon emission. Of course, one of the strategy that Saint-Gobain in general, not only Filtralite, is aiming is to reduce the carbon emission, and we have many initiatives globally to do that. Even this maybe okay, it's a different topic, but even one of my topics during the MBA process was talking about this, how the companies they are driving this initiative. And one of the cases I studied that was Saint-Gobain, that how they are driving this initiative. But of course, if you look to the like from the top overview and in the whole topic, if you have a plant and you are able to conserve or using less energy or having like energy consumption in this plant, of course you are reducing the CO2 emission in a way or another, either in direct or indirect way. So this also always been our message to the customer, that yes, you can save energy by saving energy and save less, having like less consumption of water, doing a less backwash. All of these parameters, it goes in have like save the water globally, not only in desalination or wastewater, but globally, because you are using like you are doing like a less consumption, and at the same time with saving this energy, you are reducing CO2 emission, of course. So yes, this will be one of our initiatives in general, not only for Filtralite but in Saint-Gobain.
Yeah, definitely. Yeah, to complete like the answer of Mohammed, yeah, for every project in Saint-Gobain right now, like there is a goal like to decrease like the CO2 emission on every project. They ask like to measure the amount of CO2 that they are going to be produced for that, and if it's too high, they don't keep this kind of project. And for Filtralite, the way to decrease the CO2 emission is mainly like also there is the energy decrease, as Mohammed is saying, and also a lot like as you are going to keep this filter media for a longer time, you won't need to change it. So yeah,
Exactly.
It's stuck on the road and many things like that.
Yes.
Thank you, Mohammed and Alexandre. And we'll just take maybe a couple more questions.
Sure.
So there's one about net zero liquid discharge plant, and it says we have higher silica levels in the reverse osmosis membranes. Does the Filtralite application, could it reduce the silica before entering the membranes?
I think we have one or two cases about that, Alexander. I'm not recalling this now, but I think yes, we have one or two cases. It was the same situation. But again, to our customer, if he's using, the current sand to reduce any kind of contaminant inside the feed water, yes, of course, he can do it in a better way with Filtralite. Because again, the magical key here for Filtralite is the porosity. And because you are not only, usually in filtration, you are using the distance between the particles itself. But with Filtralite, we are not only using this distance between the particles, but we are using the porosity of the particles itself. So we are doing the filtration in a double way. One, the distance between the particle, and one using the porosity inside the media itself. So that, of course, will give you better results in terms of collecting more suspended solid in the filter and avoiding this to go to the membrane. Yes, of course. But I will be in pleasure, to have this in more details with our customer. If you have a certain case and he wants to share the results with us, and yes, of course, we can study it and get back to him.
Thank you, Mohammed. So since we're well past our time, just one last question again that's looking at the future, though you've already looked at it a little bit. It's asking about future research and development plans for Filtralite to further improve its performance and applications.
Sorry, which plant again? Which type of plant?
It's just asking about what are the future research and development plans for Filtralite to further improve its performance and applications.
Of course, we have our colleagues in R&D department inside Leica with Filtralite. Always they are, providing us every, I would say that every like short time with some experiments done to filter light in different cases. They are trying to evaluate and develop, I mean, the type of the media or I would say the advantages of filter light. So always we have something new, you can check with us, and whenever there is something that we can come to our customers with a new product or something, you will read us in our innovation part. And I think we might have something on the way. This might take some time, but soon you will see also a good development done in filter light with the current situation. And yes, of course, we are doing that. I think Alexander, he want to add something here. He's smiling. So Alexander?
No, totally, you're right. Like definitely,
Okay.
I wanted to say like mainly we were focusing like in Northern Europe, and right now
Yes.
we are really happy like to having you like in the Middle East. So we want to get this product well known in the Middle East because we think we can make improvement in this market.
Of course.
Okay, so thank you both. This has been a very interesting question and answer session. Now we'd like to bring the webinar to a close. The speakers are going to be able to see and answer any other questions in the chat, the ones that have already been formulated as well. We'll leave with a deeper understanding of how Filtralite can help with water treatment challenges, enhancing the efficiency of filtration processes across various applications for more sustainable water management practices. I would like to thank our speakers for this discussion, and I would like to remind you that you're going to be able to access the recorded event on the website of Smart Water Magazine. And also, before you leave, please take a minute to answer our final poll questions. Thank you.